Example 2. Making predictions. The explanatory variable or X variable is the amount of the lottery jackpot, and the response variable or Y variable is the corresponding number of lottery tickets sold. Jackpot amounts are in the millions of dollars and the numbers of tickets sold are in millions. For part A, what we want to do is we want to use the regression equation or the regression line where y is equal to negative 10.9 plus 0.174x and the jackpot tickets data to predict the number of lottery tickets sold when the jackpot is 625 million. How close is the predicted value to the actual value of 90 million tickets that were actually sold when the Powerball lottery had a jackpot of 625 million? So the first thing is that we need to determine if this particular equation is a good model and use the regression equation for predictions. So in order to make sure that this model works, we want to go ahead and then put this into StatCrunch. So the first thing we're going to do is we're going to come in here, we're going to put in our first column, which is jackpot, and put all those values in, and then for tickets we have our values here. So we're going to go ahead and go to graph, select scatterplot, come in here and put in our X variable, which is the jackpot. The Y variable is the tickets. Okay, and then we're going to come down here and you see where it says overlay polynomial order. We're going to select 1 because it's a linear equation. And then we're going to put in the equation that we have here for the regression line. So we're going to go ahead and select that. And C subscript 0 is going to represent the y-intercept of negative 10.9. And then C1 is going to represent the slope, which is 0.174. Okay, and then we know that the x-axis is the jackpot. We know the y-axis are the tickets. And then make sure that we have our horizontal and vertical lines. And then select compute. And therefore here is our graph. And so now what we want to do is we want to determine whether this line fits that data. So when we look at that regression line does fit the regression data. So we would say the following. We would say that the regression line fits the points well. Also, there is a linear correlation between Powerball jackpot amounts and numbers of tickets sold. Okay, now because the regression equation of negative 10.9 plus 0.14x is a good model, we want to substitute the value of x, which is equal to 625, into the regression to get a predicted value of 97.9 million tickets sold. So up here, this is the question. We want to find out, can we plug this value in? So we know the value of x is equal to 625. And then we're going to plug it into this equation. So let's go ahead and do that. So we have the following. We have negative 10.9 plus we have 0.174 times 625. And then that gives us 97.85. If we round that to one decimal place, we get 97.9. And that gives us a predicted value of 97.9. So the actual number of tickets sold was 90 million. So the predicted value of 97.9 million tickets is pretty close or pretty good. Okay, part B, it says predict the IQ score of an adult who is exactly 175 centimeters tall. Okay, now what we're going to do now is, this is a bad model. And the reason why is we would just use the mean value for the predictions. Okay, knowing that there is no correlation between somebody's height and their IQ score, we know that a regression equation is not a good model. So the best predicted value of IQ score is the mean, which is 100. Now we don't have the values to find the mean of that, but we would use the mean. So in this case here, we know that from our data, we would say that the mean value of the y's would then be 100, and therefore that would represent the best predicted value. So here's our interpretation. In part A, the paired data result in a good regression model. So the predicted number of tickets sold is found by substituting the value of x equals 625 into the regression equation. However, in part B, there is no correlation between height and IQ. So the best predicted IQ score is the mean IQ score of the mean values of y, which is equal to 100. Now, key point, use the regression equation for predictions only if it is a good model. If the regression equation is not a good model, then you're going to use the mean values for y for the predicted value of y.